everyone, we are continuing our unit on limits with left and right-sided limits. So they're exactly what they sound like. They want to know what's going on as we approach from the left and from the right. So as we have x approaching some c with a little negative sign, that means from the left. Okay, and if we have x approaching c from the right with a little plus sign, that means from the right. And remember, if there's nothing there, that means both. Okay, so from the left and from the right. And again, if those do not equal, then we have a problem. Then the limit doesn't exist. Alright, so let's go through our first example. We have the reciprocal function shifted to the right by 3. So I have a vertical asymptote here at 3. I know my function will look roughly like this. Okay, so I want to know what's happening as my function approaches 3 from the left. Okay, so I am following my function, and as I approach 3 from the left, it looks like I go down. So my answer will be negative infinity. Alright, now I want to know what happens when I approach from the right. So if I approach 3 from the right, it looks like I shoot up. You gotta do the sound effects. So it looks like I go to positive infinity. So my question to you is, do these two match? Are they the same? I don't think they're the same. I don't think negative and positive infinity are the same. So since that is the case, I say that my limit does not exist. Right? It has to be the same coming from both directions. Alright, I have the limit as x approaches 3 of 1 over x minus 3 squared. So this is a graph that I would recommend that you know. It looks like that. So I've shifted to the right by 3. So again, I have a horizontal asymptote at 3, and my graph will do roughly this. Makes sense because I'm squared, so no negatives. Alright, so I want to know what's happening from the left and from the right. So as I go from the left, it looks like I go all the way to infinity. So I'm actually going to write that. So my limit as x approaches 3 from the left of, I'll just call this f of x for short, equals positive infinity. And from the right, it looks like I go up as well. So my limit as x approaches 3 from the right of f of x is also positive infinity. So do these match? Yes, they do. So that means that my limit is positive infinity. Right, that is an okay answer to get as a limit. Keep in mind that this is not asking what the function equals at 3. Those are very different questions. That's actually a question of continuity. This is simply asking what does your function approach as your inputs get closer to 3. Alright, next, throwback, we have the signum function, if you remember. That was the absolute value of x over x. Okay, so the graph looked like this, where this was 1 and 1, sorry, negative 1 and 1. Okay, but I've shifted to the right by 2. And I want to know what's happening as I approach 2 from the left. So at 2, I have my function. This is 1, this is negative 1. Alright, and from the left, so as I approach 2 from the left, I follow my function, and it looks like I approach negative 1. Okay, now I approach my function from the right. So if I approach 2 from the right, I'm going to start up here, and I go nope, right here, and it looks like I approach positive 1. Again, we are not asking what the function actually equals at 2. The function does not exist at 2. Okay, I'm asking what do we approach. Do these match? These do not match. So my limit does not exist. Easy peasy. Alright, next example, we have a little bit of editing to do. It didn't print for some reason. We have the greatest integer function, or a step function, and y is the greatest integer that's less than or equal to x, if you remember. So what that looks like is this. Let's make that clearer. want to do is actually take my greatest integer function, shift it to the right by 2, and then solve, right? So if I shift to the right by 2, that means that's where I am starting. So that's the point. And so on and so forth. It would actually go, I drew that a little big. It would look more like this. Okay, a little squished. So I'm asking, if I approach 1 from the left, a 1 being right here, then what will my function approach? So if I'm approaching the point 1 from the left, my function is down here. So if I'm approaching from the left, it looks like I approach -2. Alright. If I approach 1 from the right, I'm up here. It looks like I'm approaching -1. Again, these do not equal, so my limit does not exist. Okay, let's move on. So sometimes it helps to use our limit properties that we learned a few notes back. So if I consider this mess of functions, I want to know what's going on. So I'm just going to split this up into 2 functions actually, because I noticed that I have the signum function right here. So I'm going to consider this as the limit as x approaches 2 from the left of x cubed times my signum function shifted to the right 2. Alright. I already know kind of what this looks like if you don't remember. It is my greatest integer function. And it looks something like this. This is much better than the one I drew a second ago. And I want to know what's happening as I approach 2 to the left. Okay, so 2, if my point's here, if I approach from the left, it looks like I approach -1. Right, so I know that the limit as x approaches 2 from the left of my signum function is -1. I'm not evaluating the limit in general, so the two-sided limit only from the left, so I will get an answer here. For x cubed, there's not really a problem. I can just plug in 2 because I know the limit exists at 2 for x cubed, as it does for all points, because x cubed is a polynomial. So I'll just plug in 2 here, and I'll get 8. And so my final answer is, that's not true at all. Just testing you. -8. Okay. Next one, I have, again, it didn't print for some reason, but my greatest integer function here, and again, I am approaching from the left. So this time I'm actually going to split this into 3 different functions. I have the limit as x approaches 2 from the left of x cubed. I have 1 over x minus 2, so my reciprocal function shifted to the right 2. And then I have my greatest integer function shifted to the right 2 as well. Okay. So thankfully we already did the work for this a little bit. I already know the limit as x approaches 2 from the left of x cubed is going to be 8. I already know that the limit as x approaches 2 from the left of 1 over x minus 2 is going to be -infinity. Hey, and if you have trouble visualizing that, think about the graph. Hey, and I'm approaching 2 from the left, so I'm going to go down. Alternatively, you can think about left is always going to mean smaller numbers in math, because that's how number lines work. And so think about what happens if you plug in a number smaller than 2. If I plug in a number smaller than 2, like 1, I will get a negative number. And I know that I have an asymptote there, so I know I'm going to approach -infinity, okay, instead of positive infinity. Okay, and then the last one here, my greatest integer, we actually just worked with that. We'll get -1 as a result. So ultimately, what I'm going to end up with, you can do some basic operations with infinity. It doesn't always work, but 8 times -infinity will still be -infinity. Right? It just absorbs the 8. But -infinity times -1 will become positive infinity. Right? So the negatives there will actually work like normal. Okay, now sometimes you can overthink it, so please do not do that. If you have an easiest way to solve, then please solve that way, right? That's what Occam's razor says. The easiest solution is obviously the best, or the simplest solution is the most obvious one. So what I will end up doing is, immediately I see I can factor this, so I have the limit as x approaches 3 from the right of x minus 3, x plus 2 over x minus 3. These will cancel. I have the limit as x approaches 3 from the right of x plus 2. If I just plug in 3 now, I'll get 5. Okay, so cool. I got my answer. That's great. But where could we have gone wrong? Well, there's several spots, right? So the first thing I could see is if you wanted to split this up. Let's just explore what happens. I'll do all this in pink. So if I decided to split this up into x squared over x minus 3 plus negative x over x minus 3 plus negative 6 over x minus 3, would we still get 5? Right, so let's explore this. What it looks like to me is we will end up with an infinity here. It looks to me, again, we'll end up with a negative infinity here. And we'll end up with another negative infinity here. And you might look at this and be like, hey, infinity minus infinity is 0. But it actually doesn't work that way. Infinities are of different sizes, and that's one of the operations that does not work with infinity. You cannot really do that. Multiplication's fine, but addition and subtraction, it doesn't work very cleanly. And so here, this is just a mess. This is just bad. This is sad. All right. Bad situation. You know you did something wrong. Now, what if we factored and then we split? So once I got to this point, what if I decided that I wanted to split for some reason? Well, there's two ways that we could split, x minus 3 and then x plus 2 here to the side in its own group, or we could split into x plus 2 over x minus 3 and then x minus 3 by itself over here as well. Alright, so one of these ways is fine. This way, this will still cancel out and we'll end up getting 5, and that's just dandy. Good job. This way is more weird. So if we plugged in 3, right here I would get infinity, and over here I would actually get 0, and this is what we're talking about in this note. So if you end up getting 0 times infinity, that is, again, what we call indeterminate form. We talked about this briefly in the past, and we don't quite know what to do with that. When you get indeterminate form, that just means there's something else you have to do to solve the problem. So this is bad. The reason why we would call this indeterminate form is because typically what we said indeterminate form was 0 over 0. You can rewrite infinity times 0 as 0 divided by 1 over infinity, which, I don't know what I'm doing, 1 over infinity, which we typically say the limit would tend towards 0 over 0. These aren't exactly equal, but so that's where this form of indeterminate form comes from. So this is also, it's not as bad as this situation. It's just kind of like a, meh, you gotta try again. So do not overthink these problems. Go with the simplest solution first. That's really the first step, is when you're working through these problems, you look at it and you're like, okay, I can plug in. I know to expect to get infinity. I know to expect to get 0. I know to expect to get does not exist. Right? So those are the things that you're thinking about as you get more and more comfortable solving limits. All right, so this is your homework. Let me know if you have any questions, and have a fantastic rest of your day.